So 0 to fractions, the highlight of this week's session. Let's just do the outcomes to start with. Define equivalent fractions and simplify where possible. This word, equivalent, what does that mean, I think?
Same as.
Same as. This is the key to fractions. If you know what equivalence is and how to do it with a fraction, the fractions will never be an issue again. So we'll spend a lot of the time looking at equivalence, okay? Because it helps you compare fractions, subtract fractions, add fractions, do all sorts of clever things with fractions. Helps you with decimals and percentages and all sorts of things. And it's a lot of people forget about it. So equivalence is the key, okay? Then we're going to show you how to add, subtract, multiply and divide fractions. Okay, in a logical way, we're going to look at whole numbers first and then introduce fractions and show you there's nothing different about them. And then demonstrate the relationship between fractions and decimals. Just going to touch on that a little bit at the end. Next week we're going to do decimals proper and percentages. So this is just going to knock a bit out of that lesson. And then recognise these things called recurring decimals and identify which are and aren't recurring decimals. Anybody know what a recurring decimal is? Anyone heard that phrase before?
Is it where it's the same number repeated over and over and over?
So a third is 0.33333333. Right. So recurring decimals are these decimals that go on forever. One, we're going to find out why they exist, and two, we're going to show you how to write them down properly. Okay. So they're the 4 outcomes for today. Like I say, most of the time will be spent on these first 2. The cunning plan. Fractions, again, applies to all 3 units, green, blue and red, units 1, 2 and 3. And if you can get your head around these, certainly it's the building block for ratios. So when we come on to ratios in a couple of weeks' time, a ratio is essentially a fraction. So if you get your head around fractions, it makes ratios a lot easier. So a smart recap. Spent a fortune on those show me boards. I want you to do 4 questions for me based on what we did last week. Things that might kick in today. So question 1, what is the answer to 8 minus 2 plus 4? Question 2, what is minus 3 plus minus 2? Question 3, minus 10 times minus 50. Probably the most important of the 4 questions as your smart recap on what we did last week is 25 divided by 4. Let's go through them then. They're up there for a reason. Question 1, any volunteers for question 1? What's it all about, Alfie? It's all about odd maths or big maths. So what am I trying to get out of you here? What's the first thing I'm going to do there? What does big maths tell me to do first? Is that right?
No, it's 8 minus 2 first.
Right. That's the mistake I told you to be aware of. Addition and subtraction are at the same level. So when you're left with a question with addition and subtraction, the A doesn't come before the S. They're at the same level. So you read it from left to right. So the first thing you do here is 8 minus 2, which is 6. Add the 4, gives you an answer of 10. If you do the addition first, because you've fallen into that trap, then you end up with 2. It's the wrong answer. That's why we have big maths. It's telling you the correct order to do things. So the addition and subtraction are at the same level, so you read them from left to right. Let's look at the next one. What's this one all about? Why did I give you that one? What did we do last week?
Positives and negatives.
Good, it's the sign rule. And we had a process for dealing with the sign rule when we were adding. Can anyone remember what step 1 was? We had 3 steps to do addition and subtraction when we had nasty negatives. Yeah, that's step 2. So step 1 was take the first number, that's your starting point on your number line, remember? So step 1 was, I am starting at minus 3. That's my first number. Step 2 was deal with your conflict. So I've got a plus and a minus, and the sign rule says what? It's when the signs are different, it's negative. So the outcome of those 2 is a negative. So I've got minus 3. I'm going that way. And how far am I going that way? The 2. So I end up at minus 5. So the correct answer for this one is minus 5. Okay? If you're getting these wrong, you need to look at the YouTube video and get more practice on big maths and the sign rule. Again, question 3 is the sign rule. So this is subtly different. We had a different process for multiplying and dividing when we had negative numbers. So what was step 1? What did we look at first?
Where you were on the thing.
Don't look at the number line this time. What did we look at? What was step 1 when we were multiplying and dividing negative numbers? The signs on the two numbers. So we look at minus 10, so what am I dealing with? A negative and a negative. What's the outcome? A positive. So we end up with a positive, and then just do the maths. 10 times 50, 500. So you end up with a positive 500. Okay? Bit rusty at the moment, it will come. You can't get away from these, they're going to be every week. Okay? Finally, 25 divided by 4. Just testing your basic rules, and we talked about division when there were things left over. So 25 divided by 4 is 6, remainder 1. And that's brilliant because that tees us up nicely for fractions. That remainder 1 means something really, really important today. Right, let's have a chat then. Talk to me. What's a fraction? What do you understand by a fraction?
A portion of something.
A portion of something. I like that. Portion. How does it look? What does it look like? How do you recognise a fraction? Give me an example. Ooh, the big words. Right, that's good. Brilliant. Just saved me. A numerator and a denominator were the buzzwords that came out there. These are two buzzwords that we will need. So you have a line, and the number on the top is called the numerator, and the number on the bottom is a denominator. Okay? And what do they actually mean? If you were talking plain English about a fraction, what does that mean? What does this 1 line 2 mean to you? What's it saying?
The denominator is the whole, and whatever's above is that section of it.
Good. So I've got a whole, and that denominator is telling me how many equal parts to cut it up into. So it's telling me I've got something, and I'm going to cut it into 2. And the number on the top, the numerator, is saying I'm actually only interested in one of those 2 parts. That's really basic fractions. That's how in words we would describe a fraction. A numerator and a denominator, and I'll use those all lessons so we get used to them. Okay? And it's saying I've got something that I'm cutting into 2 equal parts, and I'm interested in one of them. If I had my pizza and I cut it up like that, the fraction there is not a third. I haven't cut it into 3 there. Well, I have, but they're not 3 equal parts. So you can't say this has been cut up into thirds. And when we talked about misconceptions a couple of weeks ago, that's a misconception a lot of people have. What you have to have as a denominator is 3 equal parts. So if you've got thirds, it kind of looks something like that. Okay? So that's just a visual representation, and we'll have a look at that closely. If we look at our fraction, our 1 over 2, and we're not representing it in words or pictures, what does that mean in mathematics? What does that 1 over 2 mean? We've come across it. Division. Brilliant. It means I've got 1 and I'm dividing it by 2. It's just another way of writing this. They are the same thing. Absolutely the same. That's just a quicker, easier way of doing it. It saves me a space, a funny division sign that I can never find in Microsoft Word, and another space. Yeah? If I do it like that, 1 line 2, it's quicker, it's easier, it's more user-friendly. So all a fraction is a division question that we haven't actually carried out. We've just left it as it is, okay? If you actually did 1 divided by 2, let's do it. Last week we had a process for doing division, but I haven't shown you how to do long divisions yet. I've got 1, and I'm dividing it by 2. So 1 is the thing that goes into the bus stop, and I'm putting 2 into it. This time we've got this decimal point here, because after the 1 we're into our decimals. 2 does not go into 1, does it? So it's 0. Carry over the 1. I'll put a 0 there because I need it. I can put as many zeros as I like. 2 goes into 10 how many times? 5. So the reason a half is 0.5 is because when I actually divide 1 by the 2, I end up with 0.5. Magic, isn't it? And a lot of people can't see this. They tie themselves up in knots with fractions because they're imagining pieces of pie or bars of chocolate or whatever, when really that's just telling you to do a division. It's telling you to divide 1 by 2. And that's the mathematical way that we look at fractions. So let's go back to our visual representation and talk about the basics of fractions. So I've got a whole of something. Doesn't matter what that thing is. It's 1. If I divide it into 2 equal bits, it's a half. 3 equal bits, it's a third, quarter, and so on. So unlike normal numbers, where the number gets bigger and bigger, 3, 4, 5, 6, the number gets bigger, with a fraction, as the denominator gets bigger, the piece of the pizza or bar of chocolate or whatever is getting smaller, okay? And they might ask you to sort simple things. They might say, oh, John says that 5 is less than 6, therefore a fifth of a bar of chocolate is less than a sixth of a bar of chocolate. That kind of logic doesn't apply, okay? Because the bigger the denominator, the more things I'm chopping the thing up into, okay? Visualising fractions, and they can quite easily test you on the visual representation of a fraction. So all you need to remember is to create your fraction from your visual representation is to say how many things is it divided into, that's your denominator, and then how many things am I interested in, the things that are coloured in this case. So here I've got 8 pieces and I'm interested in 1. Here I've got thirds, so it's cut into thirds and I'm interested in 1, and so on. Okay, everyone happy with that? The thing that a lot of people get caught out on, and we don't really revisit until we get onto measurements in March, I think it is scales. Because a scale, like these lines, is a fraction. Okay. So when you look at these lines, these scales on rulers or syringes or wherever you come across scales in day-to-day life, they are fractions. They're dividing something up into nice little bits, either in half, thirds, or whatever. So the way they can give you a visual representation of fractions, bars, pie charts, or these line bars, okay? So sometimes they're going to ask you to order it. If they give you just a numerator of 1, it's easy. But if they say to you, compare 2/5 with 3/8, suddenly you're not going to have this in the exam. You need a mathematical technique for doing it, okay? And that's where this thing called equivalence comes in. Equivalence is what? The same as something, yeah? Brilliant. So, I'm going to make you all maths geniuses tonight by giving you the secret of fractions, and it is equivalence. So, when I look at my fraction, whether it's a pie chart or whether it's written words, I think my finger's losing sensitivity. There we go. We'll stop it about there. If I have something that is a half, and I'll do it in words as well. So I've got a half here, okay? It's exactly the same as 2 quarters, isn't it? 2/4. They're the same thing, which is exactly the same as 3/6, which, funnily enough, is exactly the same as 4/8. Okay? They're all the same thing. They're half of something, can't they? So, what is equivalence? Can you see what we're doing with our half? How do I get from here to here? How do I get from a half to 2/4? Sorry? Double it. Double what? Both. Brilliant. That's what equivalence is. If you do the same to the top of a fraction and the bottom, you still have the same fraction. You haven't changed it. So here, I'm multiplying it by 2 on the top and the bottom. So I've got the same fraction, but it's written in a different way. I can use it for different things. Okay? We go to the next one. What have I multiplied the top by to get the 3? Multiplied it by 3. What have I done to the bottom? Times 3. So again, if you do the same to the top as you do to the bottom, the fraction doesn't change. It's exactly the same fraction, just with a bigger numerator and denominator. But that equivalence is the secret to fractions. It's a secret for comparing fractions, it's a secret for adding fractions, and it's a secret to subtracting fractions. It's also the secret for finding gaps between fractions, which we'll come on to as well. So this thing here, equivalence, if I was going to give you one tip with fractions, that is it. That is the most important thing you need to know about fractions. Because when we start swapping between fractions and decimals and percentages, equivalence will let you do it really quickly. Okay? So everyone understand what equivalence is? Okay, let's carry on. If we come back the other way, it's called lowest terms or simplifying a fraction. So let's start at this end. In fact, let's rub that out. Let's say we can see 4/8 here. So instead of multiplying the top and the bottom by a number, if I can find a number that divides into the top and the bottom, We go the other way, don't we? We make the numerator and the denominator the same without changing what our fraction is. So 4 over 8 we know is a half. So what happens if I divide the top by 2 and the bottom by 2? What do I get?
2 over 4.
2 over 4. Can I divide them again?
Yeah.
Yeah. If I divide by 2, I get 1 over 2. So I'm coming this way this time. I'm actually simplifying a fraction. So going that way is making an equivalent fraction. You're getting bigger. And if I come the other way and I can find a number that divides into the top and the bottom, I'm doing what they call simplify. As a general rule, at GCSE Maths level, they will expect you to simplify a fraction. Generally they'll say, and simplify it to its lowest terms. But if they don't, and you can see it can be simplified, then you're expected to simplify it. Okay? So everyone happy with that concept? Can't begin to explain how important equivalence is, going up the way and coming down the way. Yeah? Everyone happy? Good. Let's have a look then. What I'd like you to do is just write any two equivalent fractions for this and this. So 2/5 and 3/4. What other ways could I make them equivalent? How else could I write them? Let's do this. Michael, you said for the first one, 4.
4 over 10.
And how did you get that? So I'm less interested in answers, more the processes.
Just by doubling both of them.
So he's multiplied the top and the bottom by 2. Somebody else, give me another one for 2 over 5. What's another equivalent fraction?
8 over 20.
8 over 20. And how did you get that one?
I just times by 2, well, by 4.
By 4 on that original one, or by 2 from the last
Yeah.
one? Brilliant. Okay. So can you see? They're all the same fraction. We've just written them in different ways. That's what we call equivalence. Okay. Not change the amount of pizza I'm getting. I've just cut it up into smaller pieces. Let's have a look at this one. 3/4 then. Somebody like to give me an equivalent fraction for 3/4.
6/8.
Good. And what have you done there? Good. So can everyone see what we've done there to get an equivalent fraction? What's another one then? Lefties, you've gone quiet on the left. Anything? 9/12. And what have we done there? We've times that by 3 and that by 3. Perfect. Everyone see what equivalence is? Yeah? Get in there? It'll all come together in a minute. Right, simplify to its lowest term. So I want you to go the other way now. Remember what simplification is? I've got to divide the top and the bottom by the same number, and the new fraction will be exactly the same as that one. So you're looking for numbers that go into the top and the bottom, and you keep doing that until you can do no more. So let's have a go. What number do we think goes into 6 and 9? 3. How many times does 3 go into 6? Twice. So to get from here to here, I've divided by 3. Because I've done it at the top, I have to do it at the bottom to keep it equivalent. So that becomes 2 over... So 6 over 9 is exactly the same fraction as 2 over 3. Let's do the bottom one then. Let's do it in stages, right? What's the first stage I could do? What goes into the top and the bottom? 2, because they're both even numbers. And we learnt last week, even numbers always divisible by 2. So it becomes, if I divide by 2, 4 over 6. Do we stop there?
No.
Because both even numbers again. So we do it again. Divide by 2, divide by 2, and it becomes... Happy? Same fractions. Good. Everyone happy with equivalence and simplifying? Oh, right. I'm going to save you about 10 minutes exam time and years of brain ache, okay? We're going to cover these things called prime numbers next. We really learn them in about 3 or 4 weeks' time, but I've brought them early because they're really useful things to identify, because they help you with that simplifying process. The reason I teach prime numbers now is because sometimes when you're simplifying and you get nasty numbers that involve prime numbers, you waste a lot of brain power. So anyone tell me, without looking at the poster? I see you all do. Right, what is a prime number? What's the definition of a prime number?
Any number divisible by itself and 1.
Good.
Not including 1.
Whoa, the textbook answer. Right, a prime number is any number that is only divisible by 1 in itself, but not including 1. So 1 is not the first prime number. So let's play the game then. Let's just drop this down, see if we can come up with the prime numbers. So what's the first prime number then? 2. I'm glad you did it that way around. 2. What's the next prime number?
3. 5.
Ooh. Nicole's on her own.
9. No, not 9. 11. 13.
Everyone with her?
No.
Yeah, you see what she's doing? All of these numbers are only divisible by one of themselves. You can't divide these by 2 because they're all odd. In fact, you'll never see another prime number other than 2 that is even, because it's divisible by 2. So these are only divisible by 1 or themselves. Yeah? So 11, only divisible by 1 in itself. 13 is only divisible by 1 in itself. Carry on.
17. And 19.
I want you to go up to 30.
Oh, I can't.
You've got to,
That's all
because
I
in the
know.
last 2 exam papers, they've asked you questions about prime numbers between 20 and 30. So it's only a couple more numbers. Anyone think about them? Think about the, we're at 19, 25 is divisible by 5.
Oh, yeah. 23.
23, I like 23, that's a goodie. And the last one,
29.
good. Okay. You will do well to memorise those. 1, understand what they are, and 2, they are quite hot on prime numbers, okay, and identifying the prime numbers up to 30. If you get something like this, what's 19? Good, and if it doesn't go into that number, you don't have to waste any brain power trying to work out if you can simplify it. You see what I'm saying? So if you can spot a prime number and realise, well, the prime number doesn't go into there, so it's got nothing in common with it, because I know 2 19s is 38, so it's definitely not going to go into 42. It doesn't matter what it is, okay? I can say, I can't simplify that. Does that make sense? So the reason I teach you prime numbers today is when you're simplifying fractions, if you go to this second one then, can I simplify it? Yes, because they're both even numbers. So if I divide them both by 2, I get 11 over 80. 11 is a prime number, therefore it doesn't go into 80. Stop wasting brain power and time in an exam. So the reason we show you prime numbers quite early on is so you can do this. When you're simplifying fractions and you come across a prime number as a numerator, as long as it doesn't go into the denominator, you stop. If it did go into the denominator, if it was 11 over 33, what could I divide the top and the bottom by? 11. So it would become 1 over 3. See what I'm saying? So you've got to do that check of the numerator doesn't go into the denominator. But a lot of the time it will be dead obvious like that. And it saves you wasting brain power. Okay, now we're going to do something with all that equivalence that we've just done, okay? If I want to check which is bigger, 2/3 or 3/4, and I don't want to actually do the division, the maths division, because it's a bit hard, I need to compare like with like. At the moment, I'm comparing apples and oranges. I've got a denominator of 3 and a denominator of 4. And they're 2 totally different things. If you look at it pictorially, that's what I'm saying. I've got 2/3 and I'm comparing it to 3/4. They're totally different things. They're not like for like. So in order to compare fractions, you have to make the denominator common, the same thing. And we do that using equivalence. So what we're looking for is a number that both 3 and 4 both go into. Woohoo! 12. So if I make the denominator 12 and I look at 2/3, what have I done to get from 3 to 12? What have I multiplied it by? 4. So if I multiply the 3 by 4 and I've got 12 underneath, what do I have to do to the top to keep it equivalent? So it becomes 8 over 12. So 8 over 12 is the same fraction as 2 over 3. Can you see that? Yeah? Let's do the same for 3 over 4. What have I done to get from the 4 to the 12? What have I multiplied it by? 3. So if I've multiplied the bottom by 3, okay, to get my 12, what do I have to multiply the top by? So it is 9. So 3/4 is 9 over 12. 2/3 is 8 over 12. I'm comparing apples and apples now. It's a like comparison. What I've done pictorially is I've said I've divided this into 12, and I know 2/3 is the same as 8/12. And over here I've divided this into 12s, and I know that 3/4 is the same as 9/12. So 9/12 is bigger than 8/12. Yeah? Can you see how we've used equivalence to do that? I haven't changed what the fraction values are, I've just changed the numerator and the denominator through equivalence so that they've got the same denominator. That's called a common denominator, okay, in mathematics. You're looking for something common to them both. Let's look at it as a mathematical way rather than pictures. And we're just going to cover that again, because this is really, really important that you understand it. Because this is how you're going to add and subtract and compare fractions. Okay? So I've got 2/3 here, and I've got 3/4 there. I've got apples and oranges. What I want is to blend them together. I want a fruit smoothie. Okay? So to get my fruit smoothie, I've got to blend what? The denominators. Yeah? So I'm looking for something that's common to them both. And we've decided 4 times 3 gives us 12 that is common to both 3 and 4. And we said just now, so it's exactly as I was doing a minute ago, to get from there to there, I've multiplied it by 4. To keep it exactly the same as a fraction, 8 over 12, exactly the same as 2 over 3. Over here, we've got 4 times 3 gives me my 12 there. Our equivalence, not changing our fraction, says we multiply this by 3. So I end up with 9 over 12. So now I can compare like with like, 8 over 12 versus 9 over 12. Yeah, does that make sense? And that relies on equivalence. Yeah, let's compare like with like by making them equivalent. Let's change the scales. We're not changing what the fraction is, we're just changing the numerator and the denominator into something that is common. Okay, and that is the key to fractions. Happy with comparing fractions? Yeah? So have a go yourselves. Which is smaller, 1/3 or 2/5? So let's have a look then. I've got 1/3 and 2/5. So what is a common denominator? What number could I blend together? 15, good. So if I put 15 as my common denominator, because I multiplied my 3 by my 5, just ask yourself, what did I do to get from 3 to 15? So what do I have to do to the numerator? So if I times that by 5, I end up with, so 5 over 15 is exactly the same fraction as 1/3. Yeah? Oh, we're getting there. Great. So over here, I've gone from 5 to 15. What have I done? So what do I have to do to the 2? I am now comparing apples and apples. Okay? I've got 5/15 and I've got 6/15. I am comparing fractions. Yeah? I know that the smaller fraction is 1/3. You can use this process to what we call split fractions. In some exam papers, they've given you a question like this and they've said, what is the fraction between 2 over 5 and 3 over 5? Now, when you look at it, you think, well, there's no gap. There's 2/5 and 3/5. But you can create the gap using equivalence. So what could I do to those fractions and keep them equivalent? What's the easiest thing to do? No, not simplify, but yeah, it times them, make them equivalent by 2. So if I multiply that by 2, that becomes 4 over 10. Can everyone see that? Yeah? Let's go over this side. I've got to do the same again. If I multiply that by 2, I've still got the same fraction. I end up with 6 over 10. So the fraction that is between 2/5 and 3/5 is what? Sorry, yeah. What's the fraction between 2/5 and 3/5? If I've got 4/10 over here and 6/10 over there, can everyone see that 5/10 is the fraction that's missing? Yeah? There's a gap between 4 and 6. There wasn't a gap between 2/5 and 3/5. Does that make sense? You didn't have a gap between those two? What we're trying to find is a fraction that is in between these two. And when they were as fifths, we didn't have a fraction that fitted between them. We had 2/5, and then the next fraction along would have been 3/5. So what we did is we used this thing called equivalence to make 2/5 into 4/10 and 3/5 into 6/10. Now I can see a gap. I've got 4/10 here, I've got 6/10 over there. So what fraction actually sits in between 4/10 and 6/10? 5/10. Yeah? Would you leave it as 5/10?
No.
Because you can simplify it. So it becomes, so the fraction that sits between 2/5 and 3/5 is 1/2. Does that make sense? Yeah? Can you see what I've done there? We'll just do a slow recap on it. I had 2/5 and I had 3/5. So when I'm looking at fractions, there is no gap between them. So in order to create the gap, we used equivalence to turn them into tenths. So I ended up with 4/10 and 6/10.
If you left it as 5/10,
Yeah.
would they mark it right or wrong?
Not if they say simplify it. You lose the answer mark. You
Right.
probably get a mark for the working out and lose on the answer line. The answer is
Right.
half. Yeah. But generally they will say simplify where you can, and you're expected to do it anyway. Okay. Especially for something like that. Okay. So that is splitting fractions. What we're going to do now is to test your fraction matching abilities with pictures and all the rest of it with a matching exercise. Okay. Now we're going to talk about the types of fractions. Okay. We've got a standard fraction where the numerator is smaller than the denominator. That's what most of you recognise. Okay. But a top-heavy fraction is called an improper fraction. Now, I say it's a top-heavy fraction. What does that mean? 8/3. What did we say it meant mathematically? What did we say earlier that a fraction is in mathematics? It's an easier way of writing.
8 divided by 4.
It means this. That's what that means. So when I say it's an improper fraction and it's top-heavy, all I'm saying is I'm dividing 8 by 3. So let's do that. When I divide 8 by 3, how many times does it go in? How many times does 3 go into 8? Twice. Remainder. So this time, the remainder comes into play. We said last week that remainder is really important in maths. What do you think the 2 represents? Good. Because I've been dividing by 3 and I've got a remainder of 2, it's 2/3. So 8/3 is exactly the same as 2 and 2/3. Because when I divide 8 by 3, it goes in twice. And there's a remainder of 2. And the 2 is 2/3 because that's the thing I'm dividing by, the thirds. Yeah? Everyone understand that? So when you end up with a top-heavy fraction, all you're saying is you've got a division. And when you do that division, you're interested in the remainder. Because the remainder is the fraction that's left over. So I've got 2 whole numbers and 2/3 as a fraction. Does that make sense? Anybody know what we call that? 2 and 2/3. If I get rid of the little r, which shouldn't really be there, what do we call 2 and 2/3? What sort of number fraction is that? Or number? Sorry? It's what, sorry?
2 4.
2 full ones, yeah? Yeah? So I've got a... Yeah, it's called a mixed number. Okay? 2 and 2/3 is a mixture of whole numbers and fractions. So we call that a mixed number. Let's have a look at mixed numbers. There's our 2 and 2/3 again. We've just defined it. It's a mixture of whole numbers and fractions. What if I want to go the other way? What if they give me a mixed number and I want an improper fraction? I want a top-heavy fraction. How do I reverse the process to give me my improper fraction back?
Not 2 divided by 3, is it?
Not 2 divided by 3.
2 times 3.
Good. I multiply the 2 and the 3 because I've got 2 whole numbers and I've got 3 dividing them before, so I'm going to multiply them this time. So 3 2s are 6 plus the 2 I've got in the fraction. So 2 3s are 6 plus the 2 I had before gives me my 8, and it's still all over 3. So can you see how we've gone back the way? 2 whole numbers. When I divided them by 3 before, I'm multiplying this time. So 2 3s are 6. Add the 2 that I've already got on the numerator. So that's 7, 8. So 8 is the numerator and 3 is still your denominator. That doesn't change. Does that make sense? We'll try a couple, okay? Let's do a couple. So have a go at converting these from mixed numbers from improper fractions into mixed numbers. What do I do first? Good. I divide my 7 by 3 because that's what 7 over 3 means. And how many times does it go in? Twice. Remainder 1. So the 1 goes over 3 because that's the thing doing the dividing. Okay. So it goes in twice. Remainder 1. So it's 2 1/3. So the same for the bottom one. I've got 14 over 3, which essentially means 14 divided by 3. How many times does that go? 3 times. Remainder 2. And it goes over. Did you leave it like that? Ah, good. 2 over 4 simplifies. Always on the lookout, so it becomes 3 1/2. What is the improper fraction from those mixed numbers? Remember the technique? Remember what I showed you? Kind of them.
1 times 4.
Good. So what we're doing is 1 times 4 is 4.
Plus the 1.
Plus the one we've already got is 5.
4.
And that's the same denominator. Okay? Somebody else like to try the next one? Go on then, Emma.
3 times by 7 is 21.
Good.
Add your 2 at the top, 23. So it becomes 23 over 7.
Good. And that's the improper fraction. Okay. Just to show you exam style questions. Write down the fraction 12 over 30 in its simplest form, and then find the fraction of the shape below which is shaded. I'll give you a clue. It's 5 by 10. So that's 5 there, there's 5 there, 5 there, and 3 there. Okay, let's talk about them. So for the first one then, starting off with 12 over 30. So you need to divide them both by 2's a good one, they're both even. Yeah?
6.
Becomes 6 over 15. And then what number goes into 6 and 15?
6. No, 3.
3. So 3 goes into 6 twice, and that 5. So 2/5. Or if you could see 6 goes into both.
Yeah.
Straight away, you can go back to 6. Brilliant. That's fine. It's a 1 mark question. As long as you write 2/5 on the answer line, you quit in. If you write 6/15 on the answer line, you would have dropped a mark. Okay, the second one then. What are we looking at here? 18 over 50. Yeah, 5 by 10, 50. What's that simplified down to? 9/25. Can't, because the only number that goes into 9 is 1 and 3. 3 doesn't go into 25. End of. Yeah? If you know your 3 times tables. And that's why we keep going back to times tables. You can see 3 doesn't go into 25. Good. So that's the first learning outcome. Equivalent fractions, simplifying when possible, using common factors. Okay? So that's the basics. What we're going to do now is take those basics, and for about 10 minutes, 15 minutes before the break, we're going to add and subtract, because that should be a doddle now. Yeah, because of equivalence. Let's have a look. So, the rules of number, we're going to look at add, subtract, multiply and divide fractions. So it's no different from last week, but instead of using whole numbers, we're using fractions. So let's look at adding fractions. If I have a third, and I add a third to it, it's dead easy. You end up with 2/3. Okay? I'm comparing like with like. I've got 1/3 of a cake, I add another third of the cake, and I end up with 2/3 of the cake. Okay? So when the denominator is the same, it's not an issue. No problem. No problemo. If I take away, or subtract, use the proper word, 3/4, and I take away a quarter, again, it's not a problem, because I have 3/4. I take one of the quarters away, I end up with 2/4. But that's not where I'd leave that one, is it? Because we know better than that now. What would we do? It would become a half. We'd simplify it. So when the denominators are the same for adding and subtracting, it's not an issue. Our issue comes when they start doing that. They tell you to add or subtract a third and a quarter. So this is where equivalence comes in. It's apples and oranges again. I want to make them the same. Much like we did earlier when we were comparing them, if I make them both into a common denominator, once the common denominator is there, I'm with apples and apples. Okay, so let's do this then. I've got my third and my quarter, and earlier on we learned that by blending them together, multiplying those denominators and putting them over 12, I could do something with them. And it's no different for adding, subtracting. Okay? So I've got a third. What does that become over 12? What have I done to get from 3 to 12? Times by 4, so I multiply the top by. So a third is 4/12. Let's go over here. 12 is our blended denominator. What have I multiplied it by? What do I do to the top? I have 4/12. Let's try. Take 2 for the tape. I have 4/12. I add 3/12. I end up with happy? Yeah? Because I've got like with like. Okay, have a go. Well, sorry. Adding fractions, not an issue. Everyone happy with that one? 1/5 plus 2/5 is 3/5. Denominators are the same. Have a go with that. A half plus a third. What's my starting point? What do I need to do first? Common denominator, which is 6. Everybody likes 6. Good. So what is 2 with respect to 6 then? What's a half? What have I done?
3/6.
Good. I've multiplied it by 3. I do the same to the top. 3/6 is still a half. Over here? What have I done over here? So I've got what on the top? So I have 3/6 and I add 2/6. I end up with. Yeah. So can you see how easy adding fractions is? It's all about common denominators, equivalence. This equivalence thing. Okay. Have a go at those two. See how you get on adding fractions. And then we're going to do. Okay, a few of you are stumbling, so we'll go through it slow time again. All it is equivalence, okay? So I've got apples and oranges. I've got something that's into 2/5 and something that's into 1/4. You can't put them together until you blend them, okay? So the easiest way to find a common denominator, something they both go into, is if you multiply the 5 and the 4, and it gives you something over 20. Because I know 5 goes into it, because I multiplied it by 4. I know 4 goes into it, because I multiplied it by 5. Okay? So that's the easiest way to find a common denominator. So then all you have to ask yourself is, what did I do to get from 5 to 20? Well, obviously I multiplied it by 4. So if I multiply the bottom by 4, what do I have to do to the top? Well, to keep it as the same fraction, I need to multiply that by 4. So 4 2s are 8. And I'm going to add it to something else that's over 20. So what did I do to get from 4 to 20? Well, I multiplied it by 5. If I do the same to the top, it becomes 5 over 20. So it gives me 13 over 20 as an answer. Okay? Everyone's seeing this, cottoning on. And can I simplify it?
No.
Why not? 13 is a prime number. It doesn't go into 20. End of the brain strain. Yeah? That's why we show you these things. Stop you wasting time in exams. Right. A third plus 2/5. So, you talk me through it then. What's my common denominator? 15. Good. So I've got something over 15 and something over 15 that's going to equal something over 15. Next. What am I going to do next? Good. I've multiplied that by 5, therefore I have to multiply that by 5, so I end up with 5 over 15. The next one, I multiplied it by 3, got to do the same to the top, I end up with 6. So over at the far end I've got 5/15, I'm adding 6/15. Can I simplify it?
No.
Because, and it doesn't go into 15. Okay, guess what we're going to do for subtracting? Exactly the same thing, but instead of adding, we're subtracting. So we've got that equivalence thing going on again, okay? So, got a half and a third. What's my common denominator? 6. Okay, so what have I done there? Times by 3, do the same to the top. So 3 over 6, exactly the same fraction as a half, isn't it? We all know that anyway. I've got 6 over here, so I've got a third. What have I done to get from 3 to 6? What do I do to the top? So I've got 3/6, and I take away 2/6, I get left with? You see what we're doing? We're on it now. We're on it. Good. 2 for you. Let's go through them then. First one, fronties. What's my common denominator? 30. I like 30. Let's do 30. So what we're looking at is something over 30 that represents 2/5 and something over 30 that represents a 1/6. So what have I done to get from 5 to 30? So what do I have to do to the top?
Times by 6.
Which gives me,
12.
so I've got 12 30ths, and from that I'm going to take away what? What have I done to get from 6 to 30?
Times by 5.
What do I do to the top?
Times by 5.
And that gives me,
5.
so I've got 12 30ths, I take away 5 30ths, and that leaves
8 and 30. 8 and oh. I did so well.
to that point. That was brilliant. Okay, so 7 30ths, can I simplify?
No.
Because 7's a prime number and it doesn't go into 30 if you know your 7 times tables. Okay, good.
Can I just copy
Yeah. And like I say, it's on video, it's on all the slides, will be on my course, but these the problems will. Okay, let's have a look at this one then. What's my common denominator? 28. We like 28. Let's use 28. So I'm going to convert 3/7 into something over 28 and 1/4 as something over 28. So what have I done to get from 7 to 28? I multiplied it by that 4. So what do I have to do to the top? So it becomes 12. Wrong way round. Dyslexic. Right. 12 over 28. Everyone happy with that? So 3/7, exactly the same fraction as 12 over 28. Second one, what have I done to get from 4 to 28? Times it by that 7. What do I do to the top? So I've got 12 28s, I take away 7 28s, and I end up with... Can I simplify it? No. Good. Excellent. Most excellent. 2 for you, and then I think we're on a break. What do we need? We've got apples and oranges, we've got thirds and fifths. A common denominator. So what is that common denominator? 15. So we're going to put these into 15ths and add them together. So what have I done to get from 3 to 15? So what do I need to do to the numerator? So it's 5 over 15 is exactly the same fraction as a third. Okay. And then for the other one, 2/5, what have I done to get from 5 to 15? Times 3. What do I do to the top? 6 15ths. So we add them together now that they're same. So whatever it is over 15, so it's the 11 over 15. Can I simplify it? Because, see, it was worth doing those prime numbers. Right, let's look at the next one then. I've got a half and 2 7s. So common denominator is something over 14 for both of them, and I'm going to do a subtraction. So how do they get from 2 to 14? What do I do to the top? So 7 over 14 is a half, equivalent. 2 over 7. 7 multiplied by 2 gave us the 14. What do I do to the numerator? So I end up with 4 over 14. When I do the sums, 3 over 14 is the answer. Can I simplify? No, because 3 doesn't go into 14. Okay, happy. You can see a few of you got brain fade. I'm going to introduce you to something called arithmegons. Arithmegons are simple things. All it's saying is, if you add these two numbers, you get this fraction here. So if you add these two fractions, 2/5 plus 1/3, our common denominator is 15. 5 into 15 3 times the 2 is 6, plus 3 into 15 5 times the 1 is 5. So 11 over 15 is the answer that goes in there. So when you add the two circles to get the square, if you've got the square and a circle and something missing in this circle, you subtract that one from that one to get that one. That's on the... We're going to look at multiplying and dividing fractions now. If we look at whole numbers, integers that we did last week, and I said multiply them, you would say 10 times 2 equals... Come on, peeps, it's not difficult. 20, okay? If you multiply a whole number by a fraction, by logical association, it should get what? Bigger or smaller? Smaller, okay? So what is 10 times 5? We sometimes, when we're talking about multiplying by a fraction, we sometimes say, what is a half of 10? So that link between multiplying fractions and the word of is side by side. So what we're saying is, what's a half of 10? 5, okay? So really, what am I doing? So by default, when I multiply it by a fraction, it's going to get smaller. And when we think of it in terms of what is a half of 10, we know it's 5, okay? So let's try and work out what's going on then with multiplying by a fraction. It doesn't matter whether the other number is a whole number, an integer, or a fraction. The rule is going to be the same. So how did I get 5 from that then? Well, there's something I haven't told you about an integer. If I said to you an integer is actually that, 10 over 1, I can turn an integer into a fraction, can't I? Does that make sense? 10 divided by 1? What does that make? 10. I haven't changed the number. I've just put a denominator of 1, which when I divide 10 by 1, it's just 10, isn't it? So if you think of a whole number when you're dealing with fractions as 10 over 1, the way I get 5, can anyone see how I've got 5 then? 10 times 1 is 10. 1 times 2 is 2. So when I multiply the numerator by the numerator and the denominator by the denominator, I end up with 10 over 2, which if we simplify it, or I divide 10 by 2, because that's what that means, isn't it? A fraction means that 10 divided by 2 is 5. So essentially, multiplying becomes a division. Okay? So let's use that rule to multiply fractions. And this whole thing of a half of 10, we're going to see in a minute, and we'll get plenty of practice at it. But the important thing for when we're dealing with fractions and fractions is this rule still applies when this is a fraction. So let's have a look. Let's have a look at doing some of these then. So if I say a quarter of 100, if we rewrote that in maths, we'd say 100 times 1 over 4. Yeah? That's what it means in maths terms. Yeah? The of is multiply. So if we do it over here, and we say 100 is just 100 over 1, it becomes 100 times 1, which is 100, over 4. And if we divide 100 by 4, 4 goes into 10 twice, remainder 2. 4 goes into 20 5 times. It's 25. Can you see that? Yeah? So when you're doing fractions of an amount, just think of it as a multiplication and do the problem. So that's all that is. It's 100 times a quarter, which when we do that, it becomes 100 over 4, which turns it into a division. So we've gone from multiplication to a division. And then when we actually carry that division out, it gave us the 25. Yeah? So when you're doing a fraction of an amount, think of it like that, and you won't get the wrong answer. You're going to say something.
The bottom number always be 1.
Well, when it's a whole number, we're going to come on to a fraction by a fraction in a second. So, here's a fraction by a fraction. Let's apply the exact same rule that we did with a whole number and a fraction. So the numerator multiplies the numerator. So 3 times 2 is... And then the denominator by the denominator. 4 times 3. So the answer is... Good. A half, because they're both divisible by 6. So when we simplify it, it becomes a half. So 3/4 times 2/3 is a half. So the rule for multiplying is numerator by numerator, denominator by denominator. Okay? Is that what I've got here? Yeah. So 3/4 is that way, 2/3 is that way. So we're talking about different things. So we blend them, we multiply them together, and we end up with 6 over 12.
Just how it seems.
Yeah, it's how it seems, how you would expect it. Okay? Top by top, bottom by bottom. Good. So a half times a third, top by top, bottom by bottom. Doesn't get easier than that, does it? Okay. Yeah? Have a go at those two, see what you come out with. So 1/6 times 3/5 and 3/8 times 2/9. A 6 times 3/5. Numerator,
3.
denominator,
30.
leave it like that.
10.
Good. Good, good, good. Numerator for the second one.
6.
Denominator,
72.
leave it like that. Excellent. Everyone happy? Don't forget that simplifying. It's recognising your times tables that allows you to do that really quickly. You could do it by 2 first and end up with 3 over 36 and then do it again. But if you can do your 6 times tables, you'll spot those a lot quicker. Good, good, good. Why am I going backwards? Okay. A lot of questions in in all units could be 2/3 of something. Now we've already discussed what that means and what it represents. But when you're given a fraction of an amount and it means multiplication, basically 2/3 of 60 is saying 2/3 times 60. Now, I told you earlier, just to demonstrate the association, I told you that. But let's forget about that. Let's say we know that now. What I'd like to show you is a quicker way of doing this when you get a fraction of an amount. You could divide 2 by 3 first, or you can multiply 2 by 60 and then divide it by 3. But a lot of questions, and I don't know why they do it in GCSE, I've just noticed this an awful lot, is that you can actually divide the 60 by 3 first and then multiply it by the 2 and get the same answer. And what it does is it keeps the numbers smaller, because if I do 2 times 60 first, I end up with 120, and then I have to divide it by the 3. But if you actually look at this number, what you'll find at GCSE level, especially Unit 2 when you haven't got a calculator, is this goes neatly into that. So if I do 60 divided by 3, I know it's 20, yeah? And then I multiply it by the 2, it's 40. That's the quickest way of doing it. So in maths, there's lots and lots of different ways to do the same thing. If we were doing it the long-handed way that I showed you a couple of minutes ago, what I was saying is 2 times 60 is 120, 3 times 1 is 3, and then you'd have to do 3 into 12 is 40 times, yeah? But sometimes what you find in GCSE Maths is they'll say 2/3 of 60, and when you look at it you think, oh, this goes into that really easily. It's 20, and then multiply it by the 2, so it doesn't matter which way round you do it. Okay? So there's 2 to have a go at. Just okay? Right. Let's write this out as a maths problem then. So talk to me in terms of maths. What does 3/5 of 100, how would I write that down as a maths problem to solve? What does it involve? 3/5, it's a good start. What am I going to do with it? Not divide, multiply by 100. So that's essentially what we're doing in mathematics terms, yeah? When we say a fraction of an amount, means the fraction times that amount, yeah?
So you do 3 times 1.
Right, so that's one way of doing it. So 3 times 100 is 300, and then divide it by the 5, yeah? Because it's 5 times 1. Can you see that? Yeah? So if I have 300 and I divide it by 5, how many times does 5 go into 30? 6 times plus the 0 that's at the end. So that would be 16. What I'm saying is there's another technique to do this if you want. When you're looking at this, you can say 5 goes into 10 really neatly. So 100 divided by 5 is 20, multiply it by the 3, also gives me 60, but in a quicker, neater way. So just do it the way you're happiest with. Okay? So either write it out as a maths problem and do the maths, 3 times 100, 5 times 1, and then do the division. Or, if your maths is better, you can say, I've got 100, I know 5 goes into 10 really neatly, so that's 20, yeah? And then multiply by the 3, 60. So there's 2 ways, main ways, of doing fractions. And this one will come in useful, okay, in the future.
Will this be able to test without the calculator?
Yes, Unit 2. Because these are basic numbers, right? They look like complicated numbers. I'm saying 2/9 of 180. So if we use the quick method, and you can spot this, 9 into 18 goes really easily, doesn't it? It goes 2 and the 0, yeah? And then 2 times 20 is 40. So I've done it really quickly without any hard maths. Can you see that? And this relationship between these 2 numbers is something they play on a lot in Unit 2 papers. And this is straight out of an exam. Question 8 in an exam. It's like halfway into an exam, and they're giving you questions for 2 marks that look like that. The easy way. So we said 3/5 of 45. There's a relationship between that 5 and that 45 that makes it a lot easier. So we know 45 divided by 5 is 9. And 3 times 9 is... Thank you. It's a long day. Trust me, it's a long day. Right. So, everyone happy with that? How many marks?
Set it out, though? Is that how you set it out on the...
Yeah, I'm telling the examiner clearly I'm starting off with 45, and the first thing I'm doing is dividing it by the 5, because I've got this process. It gives me the 9, and then I'm multiplying it by the 3, which gives me 27.
Working out.
Yeah. And then when I write 27 there, I get the mark.
Point, yeah.
For those of you who haven't cottoned on to the quick way of doing it, you could say it's 3/5 times 45 over 1. So 3 45s, 135, divided by 5, and then you just simplify it. So I know 5 goes into both of them. 5 into 135, now we're talking hard numbers, aren't we? We're talking 2 remainder, so let's show you how to do it. 135 divided by 5 goes in twice, remainder 3. 5 goes into 35 7 times. Yeah, so you still get 27, but the maths is starting to get slightly more complicated. So if you can spot that relationship, save yourself a lot of pain. Okay, good. Right, let's look at dividing fractions. So that's multiplying. So we've done add, subtract, multiply. Let's do dividing fractions. Now, if I say 10 divided by 2 with nice whole numbers, the answer is what? 5. Excellent. And earlier on, I said if I do 10 times a half, that's also 5. So somewhere, there's a relationship between these two. Remember what we said about those? Last week they were opposites, inverses. So if I inverse what I'm doing here, and can you see the relationship here? Anyone heard of an inverse of a 2? It's called a reciprocal. We're going to cover that in a minute. If I flip, what's 2 as a number? It's that, isn't it? 2 over 1. It's an invisible one. Yeah? We just used that. So if I flip it, it becomes 1 over 2. 1 over 2. So if I inverse what I'm doing with division, and I flip my fraction, in this case it's not a fraction, it's a whole number, it then becomes dead easy. 10 times 1 is 10. 1 times 2 is 2. Okay? Are you happy with that? Is that slightly complicated? Let's explain it again, slow time. Before I've done anything, okay, I know that 10 divided by 2 is 5. Are you happy with that part? Good. Just about 10 minutes ago, we said that when I multiply 10 by a half, I also get 5. So this hasn't changed, has it? So there's a relationship between these two. So division and multiplication, we said, were opposites, didn't we? Yeah? So if we're flipping those from dividing to multiplying, we have to flip this as well. If we're not going to touch the 10, then something has to happen to the 2. And what we do with the 2 is we flip it. And I told you earlier that 2 is exactly the same as 2 divided by 1, isn't it? So really what I'm doing with the 2 is I'm flipping it. So it becomes 1 over 2. That's how I end up getting to this. So 2 over 1 becomes 1 over 2. So now when I multiply 10 by a half, we did this a minute ago, 10 times 1 is 10, 1 times 2 is 2, and when I do that division, I end up with 5. So this process here of flipping the sign and flipping the fraction is known in maths terms as inverse and multiply, which is how we divide fractions. Okay? So I showed it to you with a whole number and a fraction. Sorry, with a whole number and a whole number, and it applies to fractions. So let's take it to that next stage. I've got a half and I'm dividing it by a third. So we know that I don't like dividing fractions, so I inverse it, okay? And I don't like this fraction here, because if I switch the sign from division to multiplication, I have to flip my fraction, which going from 1 over 3 becomes 3 over 1. So the inversing part is you flip your second fraction, and then it doesn't remain as a division, it becomes a multiplication. So when I divide a half by a third, it's exactly the same as saying a half times 3 over 1. And I showed you that with the integer, with the number 10 and the number 2. Okay, so let's try that. I've got a half times a third, 1 times 3 is 3, and 2 times 1 is 2. So we end up with an improper fraction, 3 over 2. Yeah? So the technique for dividing fractions is inverse and multiply. In other words, flip the second fraction and change from a division into something nice and easy like a multiplication, which we know is top times top, bottom times bottom. Do you want to give those a go? Yeah? Don't worry, not far to go. So, I've got a fifth and I'm dividing it by 3/7, and I've got 3/8 and I'm dividing it by 2/9. So you never actually carry out a division of a fraction. You convert them into multiplication, because multiplication is nice and easy. It's top by top, multiply bottom by bottom. So let's have a go then. I've got 1/5 divided by 3/7. The 1/5 doesn't change. What does change? The 3/7 turns into, and the division turns into a, easy. So when we do the maths for that, 1 times 7, 5 times 3, does it simplify? Because, and it doesn't go into the denominator. Hey. Right, let's do the next one then. I've got 3/8 divided by 2/9. I don't like division, so what am I going to do? I've got 3/8 still, nothing's going to happen to that. Going to times, so we're going to flip that, and 9/2, we flip this. Do the maths, 3 9s, I now know is 27. And 8 2s.
No, you don't flip it back, do you?
Oh, you don't flip it back. That's just an improper fraction. If you wanted to, you could show off and make it what? A mixed number. 16 goes into 27 once, remainder 11/16. Can I simplify it? Because, and it doesn't go into 16.
Do you have to make it a mixed number? Can you
No,
just leave it?
if the answer will tell you what to leave it as. If they don't tell you anything, I would leave it like that. But if it says, and put your answer in its simplest terms as a mixed number, you would make it 1 and 11/16, and that's it, you can't do it. Reciprocal. I talked about a reciprocal a minute ago. When we flip that second fraction, when we're doing divisions, it's called a reciprocal. So when you're dealing with a fraction, so if I'm dividing by 1/5, what does that become? If I look for the reciprocal of a fifth, it becomes 5/1, which is the same as just the number 5. So the reciprocal of a fifth is 5. Conversely, what is the reciprocal of 3? What is 3? What's invisible to it?
1.
So if I flip that, it becomes, yeah? So reciprocal. It's a buzzword that might come in the exam. It's not been in very often at all, but you need to know it. It means flipping something. And when you flip a whole number, you have to remember there's an invisible 1 under it. If you're flipping a fraction, it's dead easy. It goes the other way. But when you flip the fraction, if you end up with 1 underneath, then you can get rid of it and it's just the whole number. You see that relationship? Okay. So reciprocal. It's just a buzzword you need to be aware of if it comes up. Good. 2 exam style questions. The first one, straightforward multiplication. The second one has got 3 marks. It involves a bit of this. Okay? It's got 3 marks. You've got 3 minutes to do that one. But there's a fraction exactly halfway in between 1/3 and 1/6. What is it? And nailed the 2 marks. Yeah? So 3/4 times 2/5. What do I do? Good. The 3 times 2 gives me 6, and the 4 5s are 20. Happy? No. Good. Why am I not happy? Simplifies to, and that's probably why there's 2 marks, because there's a little bit of simplifying going on. Yeah? Got it? Yeah. Get in there. Right. I put this up because I wanted to stretch some of you, okay? We did equivalence. Now I've got a 1/3 and I've got a 1/6, and I'm looking for a fraction smack in the middle of them. So I've got a 1/3 and I'm comparing apples and oranges. So what can I do to make sure they're the same? What is that? with respect to sixths. What do I multiply the bottom by?
2.
What do I multiply the top by?
2, 2.
So now I've got apples and apples, but I can't see a gap. So what can you do? Go up again. Double it again. So if I double this, I end up with 4 over 12. And if I double this, I end up with
2 over 12.
good. And what fraction is in the middle of 4 over 12 and 2 over 12?
3 over 12.
And if I've got 3 over 12, do I leave it like that?
No.
Because
It's asking you
you can simplify. What goes into both?
3.
Good. So 1 over... So the fraction that is between a third and a sixth is a quarter. Excellent. Those of you who've got the lovely Casios, basically you can do fractions on them and they look like fractions, okay? So if you're going to do fraction work and practice it at home and just make up your fractions, if you want to check your own answers, you actually type it in as it looks on these Casios, and they're quite useful things to have. Sorry. And there's a fractions button. So it's a standard fraction, which is one numerator above the denominator. And then if you press the shift button, you can actually do mixed numbers, where you have 2 and 3/5. So that's the shift button there, and that's just a pretty standard fraction button. And it gives you empty boxes and you fill them in. I'd certainly get familiar with fractions on your Casio. Okay. So, fractions of an amount. We've done this lots of times. So now when I look at this, really quickly, what's my quick way of doing this? Good. I can see a relationship between those two straight away. So it goes in 3, so it's 30 times. 2 times 30. So there you go. What is 2/7 of 210? I've now got a really quick process to do that. I don't have to write out 2/7 times 210, which is really 210 over 1, which is 420 over 7, and then get into the hard maths. If I can see that link there, and it'll come in useful when we do percentages, you'll save yourself a lot of heartache. Okay? Good. Good, good, good. Right. I need to show you something because it comes up every paper, sort of. Okay? Sometimes we know the result of carrying out a fraction, but not the starting amount. So just then, in that last one, we talked about 2/7 of 210 being 60. Sometimes they'll give you the 60 and say the 60 is 2/7 of an amount of something. Okay? So what we need to do is turn things on their head a little bit, quite literally. Okay? So if I say to you something nice and simple, and that example we've used all the way through with 10 and 2 and 5. Okay? 5 is half of what I started with. How much did I have? So I've got 5, and it's half of something that I started with. Common sense says, without doing anything, it's 10. Well, how did I get 10? From the information that I was given.
2 times 5.
Good. So what have I done to this? I've made it a reciprocal, I've flipped it, and then multiplied it by this. Yeah? Does that make sense? So to get this amount, all I do is I flip it and multiply it by the figure that they give me. And I'll show you that with a couple of examples. If I say to you, £6 is a quarter of what I started at the start of the day. So what I'm saying is I had something at the start of the day, and I got £6 left. How much did I start with at the start of the day? Flip it. I started with £24. Yeah? Does that make sense? So in order to find out this missing amount here, you just flip your fraction when they say this is a quarter of what I started with. So here, 15 is 3/5 of what I started with. How much did I have? So I had something, I had 3/5 of it, and it came out with 15. So to work out this thing here, what do I need to do? Flip the fraction. Flip the fraction, it becomes back, doesn't it? So straight away, 3 into 15 goes 5 times, 5 times 5. That's what I started with. So if I start with £25 and I say what's 3/5 of it, I end up with 15. So going the other way, if I'm left with 15 and that represents 3/5 of what I started with, I just flip it, multiply that, and it tells me what I started with. Da-da. Okay, let's have a go. Have a go at that one. And this is slightly more complicated because there's a follow-on question. This is question 11 in an exam. Out of a question is 16. So this is getting towards the end, and this is the trickiest stuff. Okay, so I'm thinking of a number. 2/3 of that number is 60. What is that number? And then, what is 1.5 times that number? So there are two parts to this. I'm thinking of a number, 2/3 of the number, so I'm thinking of a number, and 2/3 of the number I know is 60. So in order to find the missing number, what do? Flip it. So we just say that. That can do it either way. Can do that first, can do this first, but 60 divided by 2 is 30 quite neatly. Times the 3, 90, yeah? That's how to do that. So the number I started with is 90, the number I was thinking of. Okay, everyone get that bit? The next bit, what is 1.5 times the number? Well, if that's the number, then half of it is 45. So if I add 90 plus 45, I end up with 135. Okay. What we need to do now is demonstrate the relationship between fractions and decimals. So tonight, covered a lot already, and we've still got 40 minutes to cram these two in. Define equivalent fractions. Equivalence is the key to doing fractions, because it allows us to add and subtract them, and it also allows us to sort them and compare them and find things in the middle of them. Multiplying is top by top, bottom by bottom, and dividing is inverse and multiplying. If they give you the result of a multiplication of a fraction, you just flip that fraction to find out the starting amount. We're going to demonstrate the relationship between fractions and decimals now, really quickly, and then we're going to look at recurring decimals to finish off. So, decimals and decimal place values. Everyone happy what we did last week when we looked at this and we talked about units? So if we have units on the left hand side, what do we have on the right hand side? So if I say these are units, and this is ones, and these are tens and hundreds, what's that side? The decimals. And we separate the decimals from the whole numbers using something called the decimal point. So everything to the right of that is what? When we say point something, what's on here? What does that column represent? If this is ones, tens and hundreds, what does that column represent?
Zeros.
Not zeros, not ones. Good, tenths, right? I'll wipe mine out, I'll give you the pretty version. So we know where whole numbers go with our place values, but do you realise that when you look at place values of decimals, they go tenths, hundreds and thousands. They're going down in groups of 10 as well. So we go up in groups of 10 and we go down in groups of tenths, hundreds and thousands. So if I say to you, what is 0.3? What does that represent? What is 0.3? Losing my voice, getting excited. What is 0.3?
3/10.
3/10. Brilliant. Yeah. If I gave you another decimal, if I say something you might recognise, 0.5, what is that? 5/10. So when I put decimals down, they're actually a fraction. A decimal is a fraction. It's 5/10. I don't like 5/10. Why? Because I can simplify it. I can make, what goes into 5 and 10? 5 does. So 5 goes into 5 once, 5 goes into 10 twice. So the reason 0.5 is a half is because 0.5 really means 5/10. And now we have this ability to simplify. 5/10 is a half. So the reason 0.5 is a half, you don't have to learn. You know mathematically how I switch between the two of them. Yeah? Okay? So that's decimal places. Now don't forget the placeholder, that very, very valuable 0, and they'll test you with this a lot, is if I put another 0 in there and a 6 there, what does that mean? Good. It's 600. Yeah? Why is a denominator of 100 really important next week?
Percentage.
because it applies to percentages. All a percentage is a denominator of 100. So 6 over 100 is 6%. Okay, and we'll come on to that next week. But for now, the placeholder here is really important because it's saying I've got no tenths, but I've got 600ths. And I'll give you some examples of that. Okay? Generally, they won't give you stuff to do with thousands. So if I say to you 0.24, what does that mean? What is it? 24 hundredths. Okay, 24 over 100, what does that simplify to? Divide them both by 2. 12 over 50, what does that go down to? Does that go down any further? No. So 0.24 is the same as a fraction as 6 over 25. So this relationship, a decimal is actually a fraction. I know it sounds daft, but all these years you've been dealing with decimals, you're actually talking about fractions. It's a tenth of something, it's a hundredth of something. That's why pence, 0.06 is 6 pence, because it's 6 100ths of something. Okay? So let's have a look at this then. Decimals to fractions. I've got 0.28. What does 0.28 mean? 28 over 100. I simplify it, it becomes... Can I simplify it again? Can I simplify it again?
No.
Because 7 is a prime number, it doesn't go into 25, end of. So straight away, I've gone from decimals to fractions. Yeah, really. Okay. Oh, there's a couple for you to have a go at. I've done. Let's do them quick. Trying to get everything done. So 0.7, what does that mean? 7 over 10. Brilliant. 0.0. Can we simplify it?
No.
0.07.
7 over 100.
Okay. If you wanted to compare this with that, just to show you which is bigger, and I make that 100, what have I done? Multiplied it by 10. Do the same to the top. So that's 70 over 100, that's 7 over 100. So this is a bigger fraction by a long way. 0.36, what does it mean?
36 over 100.
Simplify it.
18.
18 over 50. Again?
9.
Is that it?
Yeah.
Yeah. 0.75. What does it mean?
75 over 100.
Good.
3 over 4.
Oh, straight in there.
Yeah.
We'll do it nice and easy for everyone else. Right, divide by 5, I get. Divide by 5 again. But some people can see that straight away. So the reason 0.75 is 3/4 is because 0.75 literally means 75 over 100. For years you'd probably say, no, 0.75 is 3/4 because you recognise it. But there's a reason they're the same, and that's the reason. 0.75 means 75 over 100, which when I simplify it, gives me that lovely 3/4. Okay, good. So now we can go the other way. If I've got 2/5, there's actually 2 ways to turn a fraction into a decimal. Anyone like to hazard a guess for the first way? What does that mean? What's good? What does 2 over 5 mean? Right to the start of the lesson. What did I say? It means 2 divided by 5. So let me get me long division up. So what I'm saying is 2 over 5 quite literally means wrong way around. Oh, no, right way around. 2 divided by 5. Okay? And when we do it as a division, does 5 go into 2? No, it doesn't. We have to put our decimal point there and stick in an invisible 0. Carry the 2. Does 5 go into 20? Yeah, 4 times. So 2 over 5 is 0.4. That's one way of doing it. There's another way, a cleverer way of doing it. Anybody want to hazard a guess on how to do it? I've got 2 over 5, but I know I'm dealing in tenths or hundredths. So if I say I want to deal in tenths, what have I done? It's equivalence. Times it by 2. If I do that by 2, if I do that by 2, I end up with 4 tenths. And I know that 0.4 is 4 tenths. So there's 2 ways of converting a fraction into a decimal. There's the actually doing what the maths is telling you to do and dividing the 2 by the 5 to get your decimal. Or there's the cutesy, I'm really good at equivalence, where you say, well, 2 over 5 is the same as 4 over 10, and I know 4 over 10 is 0.4. 8 really doesn't go into 10 very well, does it? Or even 100 if we wanted to upscale it a bit more. So there's only one way to do this. What do I need to do here? What does that say to me? What's that saying? Mathematically, what do I need to do with the 1 and the 8?
Divide.
I'm going to divide them. So what am I dividing by what? 1 is being divided by 8. That's what that statement means. That's what that means mathematically. I've got 1 and I'm going to divide it by 8. So to convert a fraction into a decimal, sometimes you're forced to do it this way because this doesn't go into 10 or 100 very nicely. So 8 goes into 1. It doesn't. The decimal point kicks in. 8 goes into, we carry the 1 across, 10 once, remainder 2. Put in another invisible 0. 8 goes into 20, 2, remainder 4. And 8 goes into 40. So when I divide 1 by 8, or 1/8, that is, as a decimal, 0.125, because when I physically divide the 1 by 8, using my long division, I get 0.125. Okay? So that's how you convert a fraction into a decimal using division rather than equivalence. Okay. There's 3 or 4 to have a go. Let's have a look then. So 1/4, what does that turn into? What's that saying to me mathematics wise? 1, the other way around, being divided by 4. So 4 is doing the dividing, 1 is the thing being divided. That's what that means. This is exactly the same as that. That's what it means, okay? So 1 is being divided by 4. 1 being divided by 4. So 4 doesn't go into 1. So we put a 0, carry the 1. Invisible 0. 4 goes into 10 twice. Remainder 2. And 4 goes into 20. So it's 0.25. So 1/4 is 0.25 because when we actually divide 1 by 4, it gives us that 0.25. Most of you would have known that off the top of your head. But what you don't realise sometimes is how and why. 3/10, what's that as a decimal? 0.3, because that's what it means. 0.3 is 3/10. What's 300ths? Good. 0.03. One of their favourite questions. They'll trick you and trick you and trick you with that one all day long. Okay? Because it relates to percentages. 7 over 25. I said let's try the equivalence. Okay? So now my hint to you was if we make it over 100, then we know where our tenths and our hundredths are. So what have I done? Multiplied it by 4. What do I do to the top? So I end up with 28 over 100. So what's that as a decimal? 0.28, because that's what 0.28 means. Right, so that's the relationship between fractions and decimals. We will revisit it next week because it is important. Okay, last 10 minutes. We're going to talk about fractions and the various types of fractions that you get. When a fraction is nice and neat, when you divide 1 by 2, I get this lovely 0.5, okay? And that's what we call a terminating decimal. So a terminating decimal is a decimal that has digits that don't go on forever. So a half is 0.5. It's an example of a terminating decimal. I have to show you this because it's in the spec. I've never seen a question on it. But I have seen questions on these. So what's a recurring decimal, do we think? Goes on and on, like Ariston used to. Are they around still? Showing me age a bit. So a decimal that the digits that go on forever, right? So let's have a look. 1 over 3 means what? 1 divided by 3. So if I have a 1 and I divide it by 3, 3 doesn't go into 1, carry it over to the invisible 0. 3 goes into 10 3 times, remainder. 3 goes into 10. See where we're going with this?
Yeah.
So you end up with 0.33, and it just goes on forever and ever and ever and ever and ever. In mathematics, there's a way to save you writing all those 3's. Okay? And that's this little dot here. That means it recurs forever. So if you see 0.3 with a dot over it, and they will test you on this, it means it's 0.33 and it goes on forever. Essentially, it's a third. Okay? A sixth is another example of a recurring decimal. Okay? So a third is 0.3. In fact, should we do a sixth? No, I don't want to keep doing divisions all night. So a third we know is 0.3. A 7 is a recurring decimal. So when I divide 1 by 7, it doesn't give me a neat 0.2. It goes 0.142857. Sorry, it starts there. 0.142857. 142857. 1428. It recurs like that. So the way to show that you've got a whole host of numbers that are reoccurring is to put a dot over the first number and a dot over the last number, and it says it keeps repeating in these patterns. Okay? You won't see that very often. This is their favourite. Okay? And they'll usually say which is the biggest number. 0.33333 or, sorry, 0.3 with a dot over it, or 0.3 rounded. Okay. So just in summary, let's just look at our fractions up to a tenth. A half terminates, it's 0.5. A third is a recurring decimal, 0.33333. A quarter we know is 0.25. A fifth is 0.2. A sixth recurs, 0.166666666. A seventh we've just talked about, 0.142857, 142857, 1425. So an eighth terminates, we did that one earlier, 0.125. A ninth reoccurs, 0.11111111 forever, and then a tenth we know is 0.1 because we associate 1/10 with our decimal now, don't we? Okay, so just be aware of these definitions: terminating, recurring, and be aware of the dot over the number on a real. Come across a lot of things tonight. Equivalence is key to fractions. It allows us to compare fractions, to split fractions, to add fractions, and to subtract fractions. Okay. Multiplying fractions is dead straightforward. Dividing fractions is dead straightforward because we inverse and multiply. Relationship between fractions and decimals you should now know. From a fraction to a decimal, you can either just do the division or you can make it equivalent. To get the decimal from the fraction, okay, the decimal has place values. So it's tenths, hundredths and thousands. And you need to be able to recognise recurring decimals that are either exact or recurring. Okay? Are you happy with what we've covered?